Hello, welcome back to our discussion on working with data frames. In this very video, I'd like to show you how to filter. We've talked about the introductory part, we've talked about sorting, and here I want to show you filtering. I think we've also talked about filtering. Nope. Let's go further. We've discussed filtering in the previous video, and here I want to touch on creating columns. How do you create new columns in a data frame? To create a new column is as easy as ABC. I'll first show you the general syntax before I come back to this code where we've created this. So here's the general syntax, right? You call the data frame name, you open a square bracket, type in the title of the new column you intend to create, title of column, or let me call it column title. Type in the column title, and then you equals how do you intend to create that column. So let's say I want to create the new column by adding two other columns that exist in the data frame. I want to add column 1 plus column 2. Okay, so this is the general syntax. Very easy. Once I run this cell, a new data frame will be created called column underscore title. And how that will be created will be the addition of values that are stored under column 1 and column 2. Since there are no columns titled column 1 and column 2 in my current data frame, when I run this cell, I'm expecting to get an error, but I don't intend to run the cell, so let's just delete it. Okay, great. Now this is the exact cell I want to create, the new column I want to create. I want to call the column, I'm calling the column rating per year of age. And how do I want to calculate that rating? I'm calculating the rating by dividing the overall column by the age column. All right, and once I do that, we would like to see the first 5 entries. So let's run this cell and see how that looks like. Great, so I'm returning the first 5 entries of just this column that was created. Before we delete, so this is the first 5 entries, their ratings by their overall, dividing their overall by their age. So if we want to consider this to be rating by 5, so then Messi is the highest rated player, okay, because he scored 3.66 or 67, followed by Kelan, who scored 3.0, then Robert 2.6, then Cristiano 2.1, and then Neymar. Alright, before we delete the column, I'd like to show you how this newly added column looks like in the data frame. Let's call df. So I'm going to call df right here, and let's run this. So zoom out. Now you see the newly created column will be added to the extreme left end, the rightmost end of the data frame, not left, rightmost. Here is it. It's called rating per year of age, and these are the ratings all listed right here. Can you see that? That is how to add a column to a data frame. Okay, I'm converting this cell to a comment, running it just to take out the output. Alright, now let's learn how to delete columns. To delete columns, it's very easy. All you need to do is to call the name of the column, use the drop method, .drop, right? And you put the name, the title of the column you intend to delete, comma, axis equals 1. Now, if you put axis equals 0, then you'll be deleting the row, and this should give an error because there is no role that is called rating per year of age. So you have to remember to add your axis equals 1 attribute when deleting a column, and when deleting rows you use axis equals 0, just like I said earlier. Alright, now if I drop this particular data set without reassigning it to df, let's try this and see how that plays out. So I'll take that out. I'll also take this code out, and then when I drop this column, let's look at the output. Great, you can see that last column is no longer there. It's dropped, right? It's no longer there. Now let's call df in the next cell and see what happens. I'm going to call df in this cell right here. Let's move this above. I'll call df in this cell, and let's see the output. Oh, you can see the rating per year of age is still in the table or on the table. It hasn't been taken off. So it means that this output you can see, or you see here, is just an output that reflects what this code does, but the change hasn't been effected to the actual data frame, and that is the reason why when I called it again, we still see that column here. So there are two ways that I can show you on how to solve this problem. The first method was the method I used earlier by defining the same data set as df, or assigning it to a new variable df. Okay, yeah, which I feel is the most effective way in case you want to come back to this data set and still add this column. Alright, so once you do df equal to df.drop and you go ahead with your code, when you call df next, so if I do this and I run this cell, and then you won't see an output. When I call df again, you notice that it's no longer there because I've reassigned it to the variable called df, even though it was called df earlier initially. So that is one way to do it, but like I said, this is of course one nice way to do it, right? Because if I should go ahead, okay, even as I've done it this way, right? If I want to call it the most effective way, it means I have to give this another name. I have to call it df1 or so. But because I don't intend to come back to it, but let's say I want to come back to that guy, this same line of code, and drop this column again, because I called the name, the variable name of the data frame that I dropped it from, I still called it df, and the previous name is still df. So if I try to run this cell again, Python will be looking for the ratings per year of age, which is no longer there, and then to return an error. Let's try this, and once you see your Jupyter notebook taking time, then expect error. Okay, so here's the error. It says, let's scroll to the very bottom end of the error, key value error, or key error, rating per year not found in axis. That's because we've deleted it from the table, so it's no longer found there. Okay, but the one thing I can do to get it back there is to rerun this cell, because this is the cell where from which we added it to the table. So when I run this cell, that means that we added again, and then I come back to this. When I run this cell again, I no longer get the error, which means that it was added initially. And if I should come over to this other cell and run it again, you still find it here, rating per year of ages. So I have taught you one way of doing that, just reassigning it to the same data frame name. The other way to do that is to call one more attribute, axis equals 1, then you say in place equals true. In place equals true. So when you say in place equals true, this tells Python that, hey, this particular dropping you're doing here, please make it a permanent effect or a permanent change. As you drop it from this line of code, ensure that it is dropped from the data frame. So when I call the data frame again, I do not want to see it in the data frame. Let's run this cell, and now if I should call df again, initially it still showed up here, right? Let's call df again, and right now you can no longer find it there, because I have added this attribute in place equals true to tell Python, hey, this change you're about to effect to df, please make it a permanent change. Let it be in place. True. I hope this makes sense. All right, let's go ahead. Let's move on with our code. I'm going to comment this line because I do not want to see the output. So that is how to drop. I've showed you two different ways to drop, to delete or drop a column, either by reassigning it to the same variable name or using the in place attributes. This is cool. Now, how do we grouping data in Pandas data frame? So grouping is the keyword that is used to perform aggregations, very much similar to SQL. For those of you that are conversant with SQL, I believe you find this section very much comfortable because you easily understand what we're trying to do here. So when you are trying to perform any aggregation function using the min, sum, max, and any other aggregation function that is associated with a Pandas series or Pandas data frame, you need to group by. And here is how to group by. You have a group by method in Pandas that can group a data frame by either one column or multiple columns. In this first example, I want to calculate the overall mean of the players, then group by the age, which means that for every player who is 25 years old, I want to see the overall mean of all 25 years old players, of all 30 years old players, of all 26 years old players, and so on. That is what this function will do for me. And I would like to see the first 5 rows. When we run this, you see all the players who are 18. Here is the overall mean, overall mean ratings, their average rating by age. All 19 years players, their average rating is 68.0. All 20 years old players, their average rating is 77.0, and so on. If you want to see all of them, just let's comment this part of the code, and this will give you the overall rating of all the players according to when you group by their ages. So it means that the ages of players we have here range between 18 and 39. So there are no older players than 39 and there are no younger players than 18. Do you follow? Because we've grouped the entire record by their ages, and that is what we are seeing here. So this is one way to aggregate. Let's go back to viewing just the first 5 entries. Okay, now to select other numeric data, of course this particular record had been taken care of because almost all are numeric, but a few. So let's just select all numeric data. I add this particular syntax, select underscore data types. There's a method for df that is called select underscore data type, and then I'm saying including equal to number, so which means that I'm instructing Python to go into the data frame called df and select all the data type that has all the columns that have their data type as number dot columns. Select them and assign them to a variable name called numeric columns. So I'll run this particular code outside this cell so that we can see what that does. Let me create a new cell above and paste this. So once we run this code, I'll call numeric underscore calls, and then you see the columns, the numeric columns. Okay, if we don't want to see the numeric columns but the entire rows, the entire table, when I comment this dot columns and run the cell again, then this is what you're going to be seeing. It's giving us the outputs of all the columns that are numeric. All the columns that are numeric. I see that the last column, which was a categorical column, has been taken out. It's only showing the numeric columns. So dot columns will just give the list of the columns and not the table itself. So when I run the cell again, you see it gives us the list of the columns. So these are the numeric columns in the data set or data frame. So whenever you find yourself in a situation where you want to pick only the columns that have a specific data type, you can use this syntax, right? Select D types, which stand for data type, including numbers. So let's try including string, right, and see if this will work for those that are string. All right, so right now it's saying none. Let's try including text to see if this will work for text. Okay, this is returning data type error for us. Okay, so I think string should work. The reason why it's telling us none is because okay, let's say objects. I don't know if this will work. Okay, great. Yep, object works. So the data Python recognizes the string or the text data type as object. So now that I said let it choose the records including objects, so you can see it has selected nationality and preferred positions. In fact, let me comment this line. That's part of the code. Run this again. You'll see that indeed these are strings. So Python will refer to each strings or text data type as objects. All right, so that's it. But we're interested in numbers. That's how to filter or select columns of specific kind of data type. Either you want strings, which I refer to as object in Python, or you want numbers, which are numbers in Python, right? Great, so that is it. So those are the columns. We have a lot of them, a lot of columns that are numeric. Okay, so what do we want to do this time around? I want to group by age and calculate the mean of the numeric columns, all the numeric columns. That's the reason why I collected the numeric columns in one particular variable called numeric underscore cols. So when you put numeric columns here, which means that you've given this function, or you've given this particular group by method the list of columns. So it's going to calculate the list of all the columns and group by age instead of calculating the list of just one column overall as we did earlier. So let's run this cell. Now you see the aggregation of all the columns. It gives you the mean. Okay, these are the mean of all the numeric columns in the data set. All right, this is fantastic, isn't it? This is fantastic. So you can actually select the columns of interest and then go ahead with your aggregation. Okay, next we want to see how to group by multiple columns. I want to group by age and nationality. To do that, you put the list of columns in of course, represent them as a list in square bracket, and put them inside the group by function. Then, once you do that, you can list the columns you want to see. So if I take out this overall, let's say I want to take out this overall and just do group by this, then mean once we run this, this is going to return an error, right? Yep, this is just an error. So let's see the error message so we understand why it gives us an error. Scroll down, just go to the last part of the error message. Type error could not convert DB to numeric. So this is telling me that nationality is actually it's telling me that although I'm grouping by these two columns, but amongst other columns, because here, since I didn't filter by any column, all the other columns that are present in data frame, some of them are numeric, right, or non-numeric rather. So I would need to do that for only numeric columns if I intend to take the mean. So I can't calculate the mean of an object or the mean of or the average of a string. So that is the reason why we get this error. Please take note, could not convert DP to numeric, which means it was trying to convert the string to numeric before calculating the mean. So when I run this, I have added back my column, which is overall, which means overall is a numeric column. I've been able to calculate the average of the players by grouping them by the age and nationality. So it means that we have just one age group in England, just one age group, which is 18. Okay, age group 18, they are there in England, and then there are about 17. So age group 19 can find age group of 19 players who are 19 years old, both in France, in Senegal, and in Wales. So and their averages are all given here. So you want to look at the players who are under 20, yeah, who are 20, exactly 20, and those in Belgium and those in Egypt. So there are two in Belgium and in Egypt. We have players who are under 20, okay, and then we have players who are under 21 in Portugal, in Croatia, and so on. So that is how to group by multiple columns. You can actually do that using this syntax right here, okay, and then taking their aggregate. Yep. So again, like I said, I would like you to practice performing other aggregation functions, sum, minimum, maximum, and so on. There are lots of them. All right, whenever you want to perform any aggregation function, please can go ahead and practice it by typing them using the syntax that I've just shown to you. Okay, so I'll be stopping here so that we can discuss transforming data in the next video. I hope you understand how to group data and how to delete and how to create columns in Pandas DataFrame. Alright, thank you once more for watching this video. Please subscribe to our YouTube channel in case you're yet to do so. Like and leave comments if you have any for me from this video. Do have a wonderful day. Bye bye.